Hi there. In this video, we're going to have a look at a particular property of derivatives, which of course is that it's the gradient function. And we're going to apply that to the problem that you can see up here. So importantly, one of the big reasons for looking at the derivative is so that you can find the gradient of a function at a particular point of the function. And we define the gradient of a function at a particular point. Sorry, I didn't mean particular function, particular point. We define that as simply meaning that if we have, say, for example, a curve that looks like this, and we take a point here, then if we drew a straight line so that it touches on that point and then just keeps on going forever in either direction, that line is called the tangent line, and it shares the same gradient as the function does at that point. That's basically what it means. Just undo all that. So if you have a look at the problem here on the left here, you'll see that it sort of is exactly what we're asked to do. Consider the function f of x equals 3 sine of x. No dramas. For x between 0 and 2 pi. So just that one cycle. It says here, find the values of x for which the tangent lines to the graph of f are parallel to the line y equals 3 halves x plus 4. So it's a lot of language which is designed to really test quite a few things here. For example, what does tangent line mean? What does parallel mean? What does this mean? So it's a matter of putting it all together. So it's a classic exam style question. So first of all, we know this is a straight line, and this straight line has a gradient of 3 over 2 and a y-intercept of 4. Irrelevant. This is the bit that we're interested in, the gradient. Parallel to the line y equals 3 halves x plus 4. Parallel means that the gradients are equal. Okay, two lines are parallel if their gradients are the same. So that's what we need to know. And it says here, find the values of x for which the tangent lines to the graph are parallel. So in other words, we need to work out, based upon this function here, exactly at what points will that function have the same gradient as y equals 3 halves x plus 4. In other words, the gradient has to be equal to 3 halves. And how do we work out the gradient? Well, I'm glad you asked. We work out the gradient by finding the derivative of the function. So let's start. Here is our solution. Oh, I'm writing in blue. I'll keep on writing in blue. Solution. If f of x equals 3 sine of x, f dash of x is equal to, well, the derivative of sine is cosine, so the derivative of 3 sine is 3 cosine of x. Okay. From our problem, we need to match up the values of x for when the gradient, which is this, is equal to 3 halves. So I'm going to set this equal to 3 over 2 and go from there. Okay, I'm going to divide both sides by 3, and I'm going to get cosine of x is equal to 1 half. And just to remind ourselves that x is between 0 and 2 pi. We can do this. All right, so we know that from the unit circle, we've got cosine is equal to positive a half, which means that we're going to be looking at this quadrant and this quadrant, and we're just looking at between 0 and 2 pi, so no negative rotations. Okay, so when does cosine of x equal 1 half? So let's have a look at the angle. So we can just, well, there's a few ways we can work this out, isn't there? But we can draw this kind of thing in where we've got a length of 1 here and a length of a half here. And this is our reference angle x hat. Okay, this is part of that equilateral triangle sort of solution here. So we can see here that the cosine of x hat is going to be equal to a half when x hat is equal to 60 degrees or pi on 3. Okay, you could do all this in your head. I'm just writing it, I'm spelling it out so that you can sort of see what's going on there. So we know that x hat is equal to pi on 3. So what does that mean for what the values of x are? Well, that means that x has to be, which is here and here, x has to be equal to pi on 3. That's the first quadrant. And then it also has to be equal to 2 pi minus pi on 3. So that's 2 pi is 6 pi on 3, so it's going to be 5 pi on 3. So there are our two solutions for x. And we've solved our problem. All done.